Hello everyone, welcome back to Mathematics. So today's video will be lesson 19, everything you need to know on equations of loci. Before we go into equations of loci, let's understand what does loci mean. Alright, so loci is actually the plural form of locus, and locus is actually the set of points that satisfies a condition. So for equations of loci, this means if I join all of these points, what would be the equation like? Alright, so for our case, the condition here would be the distance from the fixed point must be the same. Alright, so here we have two cases. One is one fixed point and the other one is two fixed points. So let's focus on the one fixed point first. Alright, so the formula here, we will use this. Okay, and let's understand how does this come from. Alright, so imagine that we have a fixed point which is the red one and the coordinate is x1, y1. So now our condition is the distance from this fixed point must be r units away. Right, so one of the examples you can imagine is something like this. Right, the blue dot is r units away from the red dot. So some of y'all may argue that maybe it's not this one, maybe it can be from here, right? Because this one is also r units away from the red dot. Y'all can also argue it's this line, sorry, this dot, right? And you can imagine there are a lot of dots that actually satisfy this condition. Okay, so eventually if I join all the points that satisfy this condition, it actually forms a circle as you can see here. Okay, so now we need to find the circle's equation, which is actually our equation of loci or locus. Okay, so this equation is actually the circle's equation and actually comes from the distance formula. Right, so you can see here x2 and y2 here is actually the set of points that satisfy the condition, which is x and y, okay, which I will put here. These two parts will remain as xy, not numbers, because here x and y can be any of the points on this circle. Okay, so that's why we put x and y, because we don't know the value. Then we will minus with the fixed points coordinate, which is x1 and y1. Then we square, then we add, then we square root. Okay, so this is from the distance formula part. But because of the condition here is distance from the fixed point must be the same, which is why on the right side we need to equal to the fixed distance, okay, which is r for our example. For two fixed points, it's almost the same thing, it's just that the distance formula would be stacked upon each other, as you can see here. Right? So now here we have two kinds of distance, one is m and one is n. Right? So here means we have two fixed points, which is x1, y1, x2, y2, and then we need to find the points which is m units away from the first fixed point and n units away from the second fixed point. Okay, and then you can imagine that there will be a lot of points which satisfy this criteria, and then if I join all of them will also be a circle. So this is the locus that I need to find, the equation of locus that I need to find. So the formula is just two this formula stacked upon each other. So as you can see from the formula here, the numerator focuses on the first fixed point, right? Because here the distance from the blue dot to the first red dot, the distance must be m. That's why I put the m on the numerator side. Then the denominator side focuses on the second fixed point. Okay, as you can see here, the blue and the red dot, the distance must be n, which is why here there is n. For example 1 part A, we need to find the equation of locus P. So let's go back to the question here to find the description. Okay, so here it says point P moves that it is always equidistant from points C and D. Okay, so here we have two fixed points, and what does equidistant mean? Okay, equidistant means the point P has the same distance from C and D. Okay, so this means, an example, let's say point P is here, the distance from P to C and P to D is the same. Okay, but you'll notice that locus P is actually a straight line. It's not the circles that I showed you just now. It's because of point P has the same distance from C and D. So let's say I give an example, the point is located here. But if you see here, the blue point to point C and point D is different. So this is not one of the points. Okay, another example, if I draw here, you will also see that the distance from C and D is also not the same. So the only points that satisfy the condition where the distance from C and D is the same, it's only on this straight line. Okay, only on this straight line. For other parts, it cannot accept because of this situation like this. Okay, so later on when we find the answer, you will see that it is actually a line equation, not a circle equation. So to find the equation of locus of P, let's identify our two fixed points. Okay, so let's assume C is the first one, D is the second one, and then let's use the formula here. Right, so x will remain as x, minus with the first fixed point's x coordinate, which is -2, and then y minus the y coordinate, which is -1, and then I square root. Then for the denominator will be the same thing as well, it's just I substitute x coordinate, which is 2, and y coordinate, which is 2. Okay, and then for the right side, okay, right side is, it just says that it is equidistant, right? So this means the two values here, I can put any value, it's just that these two values must be the same, so I'll just put 1. Okay, because again, both of the distances from these 2 points must be the same. Okay, so I can put any value, it's just that it must be the same for the numerator and the denominator. Okay, then for the steps below, it will just be simplification. Alright, so what I will do is for the denominator, I will move it to the other side first, and then you imagine that both of the sides have big square roots, right? So what I will do is for both sides, square them. So I can cross off the square root, and it will be something like this, free from the square root already. Then later on, I need to expand all of these to get this one, and then I need to move everything to the left side. Okay, the final result will be something like this. So if you rearrange this answer, it's actually a line equation. That's why here the locus of P is actually a straight line. Alright? But you don't need to write your final answer in this way. You actually can stop at here already. For the next part, it's just to show that the equation of locus of point Q is this. So it actually has the same steps as part A, but here we can able to double check our answers whether it's correct or not. Right? So let's go back to the description here, which describes point Q. Okay, so it says that point Q moves that the distance from the midpoint of C and D is always 5 units. Okay, so don't be mistaken, yeah, this one is the midpoint of point C and D, not C and D. Okay, so the case would be one fixed point. Alright, so we need to find the midpoint of point C and D first. Okay, so I will use the midpoint formula to help us find the midpoint, which is 0 and 1/2, which is somewhere located here. Okay, so now we have the fixed point already, and then we have the distance, then we can use the formula to help us find the equation. So x minus the x coordinate, which is 0, and then y minus the y coordinate, which is 1/2, and then I add them up and square, and then square root, then on the right side equal to 5, because here it says 5 units. Right, so now it's just simplification. So what I will do here is for both sides I square, because I want to get rid of this square root. Right, so on the right side it will be 25. Then I need to move the 25 to the left side, and you will see something like this. But as you can see here, it's not the same as the one we need to prove. Right, if you compare the value of x squared there's 4 here. So what we need to do is multiply the whole equation by 4. Right? And then you can see that it is exactly the same as the one we need to show. For this example, it will be different from the previous examples, because if you look at here, point P must have the distance from point R and a line, as you can see here, a line x equals to -1 must be the same. So the special thing here is, previously we only have 2 fixed points, but now it's 1 fixed point and 1 line. Okay, so if we go to the diagram here, let's look at one of the examples. Okay, so one of the examples would be, the point would be here, and then this is our 2 fixed point. So one is R and the other one is S. So this S must be at this line, which is x equals to -1. Okay, and then the distances from P to S and R must be the same. Okay, so now the issue is, for this S, the coordinates, you can only find one of them. So S here, we know that the x coordinate is -1 because all of these points all have the same x. But the issue is the y. The y coordinate, we don't know what it is. Okay, so we can actually look at one of the clues given in the diagram here, which is this 90 degree. Okay, so we know that this line is a straight line, so if it's perpendicular, so this means this green line is also a straight line. It's actually a horizontal line. So this means, right, for the y coordinate of S needs to follow point P's y coordinate, which is y. Okay, it's y because we don't know. But we know that S will follow y coordinates P. That's why for the y coordinate, you need to use y instead of a value. Okay, let's look at another example to understand this. Okay, so instead of here, let's move the point P to somewhere on top. Okay, same distances from these 2 points, R and S. Okay, and then you can see that this point S actually moves from here to here. Okay, again, because one of the conditions is this must be 90 degree. Okay, so if this is 90 degree, we need to follow this point's y coordinate, which is why this y coordinate is y. So before we find the equation, you can see that this locus is actually a curve. It's not a circle, it's not a straight line, but a curve. So later on, for your final answer, you will see that the equation is actually a curve's equation. Okay, so now let's sub all the information that we have into the formula, right? So assuming that R is the first fixed point, so x minus the x coordinate, which is 1, and y minus the y coordinate, which is 0, square them, add them up together, and square root. Then the denominator, we would put the coordinates for the second fixed point, which is -1 and y, and then square root. And here, because the distances for both point R and the line must be the same, so numerator and denominator need to put the same value. Okay, and then the rest of the working is just simplifying. Alright, so the denominator put to the right side, and then we square the whole equation. It will be something like this, and then move everything to the left side, and you'll see that your final answer is a curve equation. So that's everything you need to know for equations of loci. So if you have any questions regarding this topic, feel free to put your questions in the comment section below. And thank you so much for watching. Take care, and I'll see you all in the next video. Bye bye.